This video is on inverse functions. We're going to go through a quick review of how to find the inverse of a function. Once you're given a function, just replace the x and the y variables and solve for y all over again. So we'll set it equal to x equal to 2y cubed plus 2. You solve for y again, and you will end up with x minus 2 over 2, and that's inside of a cube root, and that's actually your inverse, which we're going to call g of x. Now to verify that they are inverses of each other, you would do function composition, so f of g of x and g of f of x, and you would have to make sure that it would be equal to x. So now the existence of an inverse function is that it needs to be a one-to-one function, meaning it passes the horizontal line test, and it needs to be strictly monotonic on its entire domain, meaning it's increasing everywhere or it's decreasing everywhere on its domain. So for this example, we're first going to find the domain for this function. It's a square root, which begins at 3 and goes on to infinity, and the range, since we're staying above the x-axis, would be from 0 to infinity. Finding the inverse, just like we did on example 1, x is equal to the square root of y minus 3. Solve for y all over again. We'd get x squared plus 3 would be equal to our inverse, which we're calling g of x here. But we would have to restrict its domain to match up with the domain and range of our original function. Remember that for inverses, domain and range switch places. So now the domain for this function, once it's restricted, would be from 0 to infinity, and the range would be from 3 to infinity. But yet, the goal, the objective of these notes and of this video is, how do you find the derivative of an inverse function at a given point? Well, it's easier if I explain it through an example than to go through that box that we have there. So the first thing I would suggest to do is find the derivative of this function at the given point. So the derivative of this function is 2x. At the value of 2, our derivative is 4. Well, now find the inverse of the function. So we have x is equal to y squared. Our domain's already restricted. That would give us the square root of x is equal to g of x, which we're calling our inverse. Find the derivative of this function, of our inverse function. So that's 1 over 2 square root of x. We'll call that g prime. And now you're going to substitute in the y value that you were given into your derivative of the inverse function, and you end up with 1 over 2 square root of 4, which simplifies to 1/4. But what do you notice about the value of the derivative of the function and the value of the derivative of the inverse function? Well, inverses have reciprocal slopes. So let's do another example just to verify what was stated previously. So first we find the derivative. Oh, it's kind of late. At the value given. So this was 3x squared. Substitute in 1, and that gives us a value of 3. Well, the derivative of the inverse function at the y value, we're going to verify that it's the reciprocal of 3, which is 1/3. So first we find our inverse. So x equals y cubed plus 4. So x minus 4, all inside of a cube root, is equal to our inverse. Take the derivative of the inverse, which is chain rule. So we have 1 over 3 x minus 4 to the 2/3, and that would be the derivative of the inverse. If we substitute in our y value, we get 1/3. 5 minus 4 to the 2/3, which when you simplify it does match up to this. Let's do another example. At the derivative at 0, that would be 2 minus sine of x. Sine of 0 is 0, so we get 2. The inverse value at our y value is half. And we're actually going to stop here because this is a tricky function to find the inverse of, because we would have x is equal to 2y plus cosine of y. And up until this moment, we don't have enough tools to really solve this inverse. This next example is kind of like what you'll see on the AP test. They want you to find g prime of -1, where g of x is the inverse of f of x. Well, remember that g prime of the y value is what you're given. So when f of x is equal to -1, then the x value when f of x is -1, x is 3. So now to find f prime of 3, looking at the table, f prime of 3 is equal to -4, and remember that g is the inverse of f, well then g prime of -1 is just the reciprocal, which is -1/4. This next section is talking about the continuity and differentiability of inverse functions. We're not really going to go through this one because it's simply stating the obvious. If a function is continuous on its domain, then its inverse will also be continuous. And the same thing goes for increasing, decreasing, and for differentiability. So we're going to skip this example, so you can skip it as well. And our last example for this lesson. If g is the inverse of the function of f, and we're given f of 3 is equal to 2, find the value of g prime of 2 for the given function. Well, it'd be easiest if we find the derivative of the function, which in this case would be 3x squared over 4 plus 1. Substitute in our x value, which in this case is 3. So 3 times 3 squared over 4 plus 1. That gives us 27 over 4 plus 1, which then becomes 31 over 4. Well then, g prime of 2 is just the reciprocal of that, which would be 4 over 31. I hope this video has helped you with the introduction of derivatives of inverse functions, and I shall see you soon.